All right. So, I think last class I said that I might put that next homework up. I do have it pretty much ready to go. I want to add a few more questions too before I post it. So it should be up there either this afternoon or kind of first thing in the morning. I'll kind of get that posted tomorrow. So you want to start chipping away at those problems that'll show up there on Canvas. You can start working on those on that. I think we'll start today. I'll do a little bit. We'll kind of review to a degree what we were talking about with subsidies and taxes. I think I have an interesting example to kind of point something else out, but I just think it's like interesting related to this topic. But then kind of, I don't know, I'll decide between, I might skip around a little bit today. I might jump around the slides a bit. I did repost the slides since Monday to include some additional slides because we kind of got through some material a little bit quicker. So today and Friday, some of those additional slides, especially on Friday, we'll be going through slides that weren't on there on Monday. So if you downloaded it earlier, kind of re-download it, right? But it is updated. So, review, we left off thinking about positive and negative externalities. We then said to internalize the additional costs and benefits, we could use taxes or subsidies. So taxes were the kind of mechanism we could use to correct for negative externalities. Subsidies we could use to correct for the inefficiencies that exist in the market if we have positive externalities. So one thing I did want to review, honestly, was let's say we've got this market, the free market, so we know that the quantity and price that will exist in equilibrium if we just allow this market to operate will be where supply is equal to demand. Or kind of think about it differently, where the private marginal benefits, right, the marginal benefits of the people that are involved in this market, whatever good this is, are equal to the marginal costs of whoever's providing them. But this doesn't factor in any additional costs or benefits to society. So if we have kind of external benefits, right, or these positive externalities, we said we could think about our marginal social benefits would be whatever the marginal benefits are to the people in the market, or essentially our demand curve, but then plus this external benefit, or you can think about this as like an additional benefit or a positive externality that exists to other people in society who aren't even involved in this market. Right? This was the idea of, like I was from this education, right? Even people who go out in education benefit from people who go kind of increase their knowledge. Right? So every single quantity, we're going to have this additional benefit added to the demand curve or to the marginal benefits of the consumers in that market to get our kind of marginal social benefits, right? The total benefits to society. So when we have positive externalities, we've got a marginal social benefit curve that's higher than the demand, right? Because it includes these additional positive externalities. And the difference, right, between our demand curve and that marginal social benefit curve is just our external benefit, right? Whatever the value of that positive externality is. Okay? So we know that the quantity that society would want is way out here. But because we're only producing this lower quantity, essentially we can think about it as all the surplus that we're losing, right, is the area under the social benefit curve, but above the cost curve. Right? Now that's reflecting the deadweight loss to society. If you want to think about it, there's no deadweight loss. If this is a perfectly competitive market, like there's no deadweight loss to the producers and consumers in that market, right? They're still have this total surplus to be maximized. Right? However, to society, right, the difference between their benefits and their costs, we're losing out on this additional surplus here. So we'll label this, right? We've got some deadweight loss that exists to society. Okay? So how can we correct for this? Right? Well, we said if I was able to correctly identify the value of that positive externality of that external benefit, what I could do is just subsidize, right? So that essentially I can get this demand curve plus the subsidy to be exactly equal to whatever the social benefits are. That way, the consumers in this market will start to make decisions based off of not just their own benefit, but their benefit plus this additional benefit they're getting from, which is the subsidy of this good. So, you know, maybe this is something like tax credits. This is like maybe like a, hold on. This might be, you know, sometimes in economics you can do anything with like cost benefits, right? This one's kind of weird. What you can actually think about, this is actually a pretty relevant example. So you actually think about people choosing to have children, right? Kind of weighing out costs and benefits of how many children are valuable to a couple or whatever, right? What we actually see is that individuals, at least in the United States, are choosing kind of an optimal number of kids. It's actually a little bit lower than probably what's potentially efficient for society, or where society would want to see kind of the number of kids per, you know, per person be. So what do they actually do? They give you tax credits and things for children. They essentially subsidize. They don't say it that way because that's terrible branding. All right, they're actually kind of subsidizing. You're putting this additional value to having children. Not like I said, maybe that's not necessarily the branding that they would use, but that is kind of one of the things that we see because of these additional benefits having children. Maybe that's kind of pushes the quantity slightly higher towards that socially efficient point. That's a whole other set of issues thinking about kind of population kind of decreasing, right? We're not even like replacing ourselves at this point. I think the birth rate's fallen below 2 people, right? The average number of kids has fallen below 2, if I recall. So we wanted to push that efficient, or the quantity closer to that efficient, social efficient point. We could do things like use the subsidies. Any questions on anything here? Yeah. Yeah, if you want to think about it, it's almost like it's a shift to the right of our demand. Right? Really, the way I think it, I would explain it a little bit different, in that you can think about the reason why it's like higher is because at every quantity you've got the old benefit, but plus this additional positive externality. That's another way to think about why it's kind of shifted up into the right. Yeah. Any other questions here? So, yeah, I want to try to go through this example because I read this and I think it's kind of interesting. Try to do a little bit here. So, there was I don't remember how long ago this was. I forget what state. So I'm already starting off on a terrible foot, but that's not really relevant to the story. So if we're thinking about plastic bags, and you think about, they're pretty, plastic's not great for the environment. They might have these negative externalities that exist from the pollution that they cause. People are pretty careless with plastic bags. I think how many times you see one like blowing in the wind, right? So there's these negative externalities that are existing to society from the production of plastic bags. So if we've got the free market deciding where they want to be, let's say Q1 and Q1, right? That's where the market is going to decide for its optimal quantity. If we've got these negative externalities, where would my marginal social cost curve go? To the right or yeah, so we actually can think about in a similar way, instead of thinking about shifts to left and right, my marginal social costs, I'll get out of the way in a second, is just going to be whatever the marginal cost was to producers was before, plus this additional kind of negative externality cost, right? So it's almost going to be like at every quantity, right? I've got the, I've got the old costs plus this additional cost that's coming from this negative externality. So it's almost like I'm thinking about like a decrease in supply, right? So that marginal social cost curve is going to be kind of up and to the left, right? Representing that every single quantity, we've got not just the cost of producers, but also these additional costs to society. So we said one thing that we could do here is use taxes, right, to make people internalize these additional costs. Okay? So one thing that they did was they started to tax the production of plastic bags. I don't think it was like the number necessarily, but it was something more like the material that they knew was going to be needed to use, or sorry, the material that was going to be needed to create these plastic bags. So essentially it was the same thing, right? They're essentially taxing each plastic bag a certain amount because they knew exactly how much plastic it would take to create them. So what they were hoping was that if they got this tax correct, right, we said taxes kind of decrease that supply curve, that they could kind of shift that supply curve by including this tax up until the point where it was exactly equal to marginal social cost. And then they would be able to get this market to arrive at the socially efficient quantity. Okay. So we've got two examples here we've already kind of reviewed, right? Using subsidies to correct for positive externalities, using taxes to correct for negative externalities. The interesting thing with plastic bags was that it was almost like, so they started taxing the production, and then because they were being taxed, companies, I mean, this is how the story goes, like you imagine what this is, you don't exactly have like a real hard data on exactly what happened, but we've seen this happen with other goods, is that sometimes when you decide to tax something, so people feel not like they're paying for it. So if I feel like I'm paying for the tax, right, that's when we would see, okay, companies change their decision, they produce less. Right? But what actually happened was, after this tax, so after this tax, they actually saw, you know, this was what we were trying to get to. What they actually saw was that the production of plastic bags actually increased, right? And so this often happens when you tax a good, because the marginal cost of producers, it does reflect like their input prices and things like that. But maybe there was also this like additional, you know, they felt the responsibility, right? There was this kind of psychological cost to not, you know, they were trying to make sure they weren't polluting the environment, right? They were trying to be environmentally conscious, but it was almost like, if you think of, they had input prices plus these psychological costs. But as soon as you tax something, we kind of see a lot of other goods, the research shows that people kind of don't feel responsible anymore. So before, if there was no taxes on the production, right, because of pollution, I kind of built in, right, there was some psychological, so I didn't want to be environmentally irresponsible. But as soon as you tell me, well, there's this additional plastic tax because, you know, we want to prevent pollution from the environment, well, now companies, their thinking shifts, they don't feel like there's a psychological cost of polluting anymore because they believe that, well, we're paying for it, right? Or at least like when we alter decisions based on this additional tax, that, you know, I no longer feel guilty or feel like I need to be responsible. So the problem is, if you add this tax, but it was less than this psychological cost, so now there's no longer the psychological cost. So it was almost like, oh, it's my hand. You actually shifted the supply curve, right? Now, it still includes the tax, but it's like the cost that you got rid of was way larger than the actual tax that you implemented, right? So we see this happen sometimes with goods where, yes, taxes should correct for this, right? It should push us to lower quantities. But if that tax somehow eliminates like a psychological cost, right? And then that tax isn't greater than whatever that psychological cost was, we'll actually end up with a result where you can actually accidentally increase the production and the quantity of that good after the tax. So I remember reading about this and kind of thought it was an interesting example. We kind of have all the tools now to kind of work through it. Now I won't ever give you something like this part of an exam and kind of trick you with that, but it is an interesting example thinking through, you know, the costs that exist to producers, using these taxes to try to get to that socially efficient point, but that sometimes using those taxes we might kind of alter the cost, not of input prices, but these other costs that maybe companies kind of use to factor in the decision. I also read a paper once. It was really interesting, kind of related to this idea. So they set up, it was a daycare, and I forget how they decided who was going to go up, but they kind of, I think maybe they did it in 2 different time periods. And they start, one of the problems they have is parents always show up late, right? So the parents kept showing up late, they said, well, how do we fix this, right? So it's almost like the quantity of times people show up on time was not high. So they tried to implement this fee, right? To say, okay, if you show up to pick up your kid late, we're going to charge you $20. What do you think that would do? Well, people are going to be, their thought process was, if it's going to cost the parent $20, they're going to try a little bit harder to show up on time. Right? But what they found what actually happened was, for the parents where they kind of had this fee, they actually saw that the parents showed up even later, or showed up later more often. And the reasoning kind of follows similar to this is, as soon as they started paying for being late, they felt no responsibility at all. They almost viewed it as, okay, it's okay to do this. So this huge psychological cost before, when there was no fee and they showed up late, oh, they felt so terrible, like they made this person work late, like my kid is just sitting here waiting. But now that there's a fee, well, now the expectation is, well, they're okay with it as long as I want to pay a little bit extra money, right? And so this huge psychological cost of like guilt or whatever showing up late was completely eliminated, and they saw parents showing up, more and more parents showing up late, right? Or kind of actually saw an increase in the quantity. And you can think about that fee was really just like a tax, right? So sometimes we implement these taxes, it has reverse effects because we're kind of like eliminating this huge psychological cost, right? Now, in this class, we don't dive too much into those because it makes the models that we're thinking about a lot harder. But it is interesting to start to think about, human behavior and emotions, and how even though there's not a dollar amount like in the, necessarily exactly put on some of these emotions, they are kind of behind the scenes, right? And they do play a role. And you actually can kind of put a dollar amount on them, but it's far outside the scope of this class. Maybe after you guys get, I know not all of you are in the business college, right? After you get through like a stats course or something like that, you start to think about things like regression or something, where you could actually estimate kind of what the value of some of these different human behaviors might actually have, looking at some data. So kind of an interesting example, relevant to what we're talking about. So I thought that would be something we'd go through. We kind of talked about some other policies could just be command and control, where instead of using taxes and subsidies, the government just says, all right, the number of plastic bags each company sets or produces can only be this amount, right? Or they'll set a quota in the market. Well, that way they can guarantee they get to that socially efficient quantity, right? But more often than not, like in the US, we usually kind of see the use of taxes and subsidies to try to push us towards these socially efficient points. So another interesting one, actually, since we talked about it here, I want to kind of see where we're at with things. Right? So hopefully, I've got some things on the board that can help you. If I've got something like this, where I've got my demand curve as this green line, I've got this blue curve is going to be my supply curve, and this black curve represents this marginal social cost. Okay? So if that black curve is the marginal social cost, the blue curve is my supply curve. What subsidy would get me to that socially efficient quantity? So we've got our demand curve, our supply curve, our marginal social cost curve. This is a good example of having a negative externality. So if I wanted to kind of thinking about this tax or this subsidy wouldn't create any change in those psychological costs, right? It's just going to kind of push us towards that social efficient quantity. What would I need to use to correct for this negative externality? And looking at these two curves, the supply and marginal social cost curve, what would the value of that tax or subsidy need to be? I'll give you a little bit of time to kind of look through this, think through this, respond, kind of using this as an icon question, and then we'll come together and talk about it. You can talk to people around you too, work with each other if you want to. So do I want to use a tax or a subsidy, and what would the value of that tax or subsidy need to be? All right, I think I got most of you in here. If you haven't answered yet, take your best guess. I think I counted 27, so we should have everybody here. I'm gonna close it out. All right, well, first of all, I'm just thinking about, should I be using a tax or a subsidy for a negative externality? What should I be using? Tax. Right? That kind of pushes my supply curve closer to that marginal social cost curve. From there, the value that I would want, like the optimal tax, is just the value of that external cost. So the value of that external cost, kind of similar to how we here for our positive externality, is just the difference between those lines at any given quantity. So if I'm looking here, I could use any points, right? If I look at the difference on the y-axis, that might be the easiest. So I've got 10 to 25. So the difference between those two curves is 15. So that would be the optimal value of the tax. Questions on that one? So it sounded like I had a pretty good grasp on the fact that we should be using a tax, right? So maybe when I go in here, I'll just give people credit for how they responded with one of the tax answers. But the value of the tax that would be optimal would be exactly whatever the value of the negative externality is, which is just going to be the difference between our marginal social cost and our supply curve, which I could, determine at any of these points. Right? I could actually one up here at the quantity of 60, so 40 to 65. The difference is 15 there, right? And that's the value of the tax that I would want to charge. Any other questions on that before we keep moving? So hopefully, right, this next one won't be too bad. Right? So now I've got my supply curve. I've got this gray line, which represents my demand curve, and this green line, which represents my marginal social benefit. This looks like an example where we've got a positive externality, right? So here, what would I use to kind of correct for this positive externality, push us towards that socially efficient quantity? We'd use a tax or a subsidy, and would the value be $10 or $20? So I'll give you guys a little bit of time to kind of look at this one. Let's do this one, and we'll kind of come together and talk about it. All right, so if you haven't gotten an answer, I think there's one of you who hasn't. Take your best guess here. I'm going to close it out. All right, looks like we got everybody in. All right, so at least we're getting closer. So if I've got a positive externality, how can I push my demand curve closer to that marginal social benefit curve? I've got stuff on the board here, so I can tell it. So right away, I know it's either going to be B or D. From there, the correct or the optimal kind of value for our subsidy would be whatever that external benefit is, whatever the difference between our demand curve and that marginal social benefit is. So we can use any quantity to determine that here. If I use the y-axis, what's the difference between kind of where I'm at on my marginal social benefit and my demand curve? 180, so 20 is the difference. I could have also looked down here, right? There's quantity 40. The difference between my demand curve and marginal social benefit curve, 40 and 60. So anywhere I look there, the difference between those two curves is going to be 20. So the optimal kind of subsidy would be $20. Any questions on that one? I'm a little worried. I feel like you're paying attention. Got things on the board. Hopefully, we should be getting closer to everybody getting these correct, right? And it's very similar to what we just worked through with the tax one, right? The negative externality would do the exact same thing. My clicker's broken. So we do the exact same thing. We just use taxes and look at the difference in those lines. For a subsidy, for positive externalities, we use a subsidy and looked at the difference between those lines. Okay. There we go. So I think we'll. It's kind of. This is an interesting example. So maybe I've got another solution of how I can deal with some of these negative externalities. And this is something that's actually being used, especially in Australia right now. They've got these things that are kind of tradable pollution permits, right? So you pay for like permits to be able to pollute a certain amount of, I think it's, I've got it on the next couple slides, SO2, or I don't even know, I'm not a big chemistry guy, with a sulfur dioxide or something like that, right? So what they end up doing is saying, okay, we know that firms probably have different costs to pollute, right? Newer versus older firms, larger versus smaller. Maybe it's harder or maybe it's easier for some of them to kind of prevent pollution from their production than others. So we're going to allow for firms to kind of buy these permits, and it will also allow them to trade for each other, right? So what should happen is the firms that have the highest cost to preventing pollution, they want the permits, right? Because if they don't have the permits, they have to, spend a bunch of money to not pollute the air. However, firms with lower costs, right, they're not as concerned, right? Because even if they don't have any permits, it doesn't cost them that much to prevent their production process from polluting the air. So what they're more likely to do is that these firms that have a low cost, they start to sell away their permits to the firms that have a higher cost of preventing pollution, right? Because the firms that have a higher cost of preventing pollution actually value those permits a lot more. Right? So maybe think about it this way. If a firm, let's say to prevent its pollution, it costs them $100. Right? And the other firm, to prevent the same amount of pollution, only costs them 10. And neither one has the firm that has a lower cost, right, to prevent them from polluting that costs of 10, they're the only firm that has a permit that allows them to pollute. But what's going to happen is the second firm says, man, I'd really like that permit because it's going to cost me $100 to prevent this pollution from occurring. So they go to firm 2 and say, hey, I'll give you $50 for that permit. Well, firm 2 is still way better off there, right? Because instead of having to spend $100 to prevent pollution, they've paid $50 for this permit to be able to just pollute. Right now, they don't have to pay that $100 to prevent pollution. They have this permit that allows them to pollute. And for firm 2, that's good because, with the permit, they could just continue polluting, right? They didn't have to spend any money to prevent pollution. But once they sell it, well, they now get $50 from firm 1. And yeah, they have to spend money now to prevent from polluting because they no longer have the permit, but they're only spending $10. So like their net gain is 40. So allowing these firms to trade these pollution permits actually kind of benefits both parties. The party that's really high, has a high cost of prevent polluting, they are going to be the ones we see buy all these permits, and the firms that have a low cost, they're going to start kind of selling them away. Right? So kind of just to put some different numbers to it and kind of see them actually written down. So let's say that we had this goal, right? 2 firms are currently polluting 80 tons a month. So we want to reduce that by 25%, or we want to get pollution down to 60 tons. Well, each firm, they're producing, we'll assume for right now, they're producing the exact same amount of pollution. But for one firm, their cost to reducing for each ton is only $100. And the other firm to reduce a ton of pollution, right? A ton. 1 ton of sulfur dioxide pollution is $200. So we have a low and a high cost firm, and we want to try to reduce pollution by 10 units per firm, right? Making a total of 20 tons less of pollution. So we could just go to kind of each one and say, all right, look, we have to reduce pollution. The environment is taking a beating here. You both need to reduce your pollution, air pollution by 10 tons. Okay? So the cost to each firm there, right? For Acme, it would be 100 times 10, right? Costs them $100 for every ton of pollution that they prevent. For USC, costs them $200 for every ton of pollution. So take the cost of 1 ton, multiply it by 10, and this would be the total cost of each firm for reducing their pollution by 10 tons. Kind of making our total cost to reducing, pollution by 20 tons, whatever the sum of those two firms' costs are, right? So we've got a cost of $3,000. Is this making sense? What we're doing here?
Yeah, but why would the government impose this?
So, yeah, so this is not an efficient policy. This is our starting off point. Yeah, this is going to be our comparison. You're right. Why would they do this, right? Why wouldn't they? Yeah, we'll come back to that. I know what you're thinking, but let's assume that they did this, right? They wanted to treat both firms fairly, so they made both of them reduce their pollution the exact same amount. That's our naive starting off point. So if instead, right, we have that same goal, but we issue permits and allow these firms to trade them. So what we originally wanted was to only have 60 tons of pollution. So we're going to give out permits for 60 tons, right? Each permit maybe is worth a ton. So maybe there's 60 permits out there, right? And each permit allows the company to pollute 1 ton. So if we gave these out evenly, we gave 30 to each firm, and we didn't allow them to trade, well, then each firm would just use all of their permits, produce 30 tons each, right? And then just have the same payment to pay for the pollution that they had. So if we didn't allow them to trade these permits and we gave them out evenly, we're in the same scenario. Right? But if we instead allow them to trade them, what we're going to see happen is that the firms with the higher costs would want to trade for those permits. They value those permits more because to them, each permit has a value of $200. Right? If I have a permit and I'm that, was it USC, I think was the one, right? Then I can save $200 from preventing pollution. Well, the other firm, right, if they have a permit, it's only worth $100 to them because when they have that permit and use it, they're just kind of avoiding $100 of cost there. So, some of the other stipulations we might have is that, use all your permits, you can use, less than all 30, and then you can trade some. You don't have to trade all of them, right? So if we allow this to kind of happen, we can kind of see, okay, if each one has 30 permits, what is it optimal for these two firms to do? Well, if we think about just one situation, which is let's assume that this low-cost firm Acme decides to keep 20 of its permits, but sell 10 of them to the high-cost firm. So remember, USC had a cost of $200, Acme has a cost of $100. So Acme is going to say, okay, look, we'll sell 10 of our permits to you at $150. Well, for USC, this is great, right? Because they can produce now an additional 10 tons of pollution without having to spend $20 per ton. Now they're only spending $100, $150 per ton. So if we allow them to trade these permits, there will be a price that they arrive at that's somewhere in between both of their costs, right? In the example I gave earlier, I think it had costs of 110, so I said they'd sell them for $50. Here, the costs were 200 and 100, so kind of the price of those permits is going to be somewhere in that range. I've just chosen one of them to show you an example. So let's say they sell them to the other company for $150, right? What is this? What do the numbers kind of play out here? So here, right? For Acme, they have to spend, right? They sold 10 permits, right? So they're going to have to spend some additional money, right, to prevent pollution. And they only have 30 permits now. Their current kind of pollution production was what? We had 80 total, so 40 for each firm. So they use 20 of their own permits, but then they have to spend money to prevent the other 20 tons of pollution. So they do that, right? The other 20 tons cost them $100. So they've got a total of $2,000. That's how much they're spending. However, they sold off 10 of their permits for $150. So yeah, their cost was $2,000, but they made $1,500 in selling those permits. The total cost to Acme here was only $500. So before, their cost to reducing their pollution was $1,000. Forward here so far. Okay. So they've reduced their cost, right? For the second firm, they had the initial 30 permits that the government gave them, and they bought an additional 10. So for them, they can just use all their permits and just continue to pollute, right? Because each firm we had before 40 tons apiece. So they used their 30, right? Plus they bought these additional 10. So the only cost to them was buying the permit, right? They're not preventing pollution at all. They're just buying up enough permits to be able to continue to pollute. So for them, they bought 10 of these permits at $150 a piece. So their net cost is $1,500. So if I think about the total cost of reducing pollution here, now firm one, USC didn't reduce theirs at all, but Acme reduced theirs by 20 units. So we still saw this 20-ton reduction in pollution. The total cost of it was only $2,000, whereas before, if we just forced both firms to equally reduce their pollution, we still only saw a 20-ton reduction in pollution, but the net cost of it to society was $1,000 higher. Right? So these tradable permits allow us to kind of get the same result, the same reduction in pollution, but at a lower cost. Right? And that's essentially because instead of just like demanding every firm cut their pollution by X amount, we're being more efficient, right? The firms that have a higher cost, we're allowing them to trade these permits. They're going to buy all the permits, right, and avoid kind of the high cost of preventing pollution. While these firms that have a low cost to preventing pollution, the incentive's there now for them to trade away all these permits and then just spend the money to reduce pollution, right? Because if I can sell my permit for $150, but it only costs me $100 to prevent the pollution, like, yeah, I'm going to sell all my permits with, right? So I'll make $150 from selling it, and then to prevent it, I only have to spend $100. My net gain on each ton of pollution here is essentially $50 per ton. So, kind of we've run over positive negative externalities a lot this week. I think this is expected both of the final have kind of these examples on there. And this is kind of related to it. I'm probably not going to do anything, make you like reproduce all the values here or work through an example like this necessarily. But it is something that's interesting that, like I said, specifically Australia is using a lot right now in trying to prevent pollution, and it kind of forces these low-cost firms to prevent a lot of pollution that they're putting out there in the air or the water or whatever it is. Don't have enough time where I can really dive into it. So I'm going to skip around a little bit. So let me see here. Oh, we'll include this with the Coase theorem on Friday. So we'll start talking a little bit today about public goods. We'll probably pick up on this conversation in the next class. But public goods are going to be things like what I've got here: national defense, state parks. Right? Think about this as like common areas that everyone can use, common things that everybody kind of benefits from. Right? I don't know, maybe even think about like the interstate system, right? It is something that's a public good. We can all use it, right? Really anything that kind of the government is building. So one thing we say with public goods is we say that they're non-rival, and that kind of just means that you using it doesn't prevent me from using it, right? So you enjoying the benefit of national defense does not prevent me from enjoying the benefit of national defense, right? We all benefit equally. Right? So the problem with public goods is we usually don't get to a socially efficient point unless we have some type of governing body to provide these public goods. So think about it this way. Unless I can charge money for it, right? Why would I build as a private individual an entire interstate system that anybody can use, right? I mean, it's an extreme cost, and I'm only getting my own benefit. I doubt anybody, unless maybe there was like the owner of like, let's say that we had a monopoly market or a monopolized market in the trucking industry, maybe for that company, it would make sense to build an entire interstate system if one didn't exist. So the problem with public goods is the total benefit to society is huge, right? The total benefit to society from having this huge interstate system or having national defense is immense or unmeasurable to some degree, right? However, no one person benefits enough that they're going to spend enough money to create an entire army, right, for their country. So the idea is we need to all pool our resources together, because total we all benefit a lot, but for every one individual, right? Maybe every individual benefits what, $10 if we wanted to put a dollar amount on it from having the interstate system or from having national defense. Well, if everyone benefits $10, there's like 300 plus million people. The total value to society is what? $3 billion $3 billion there. Right? So, we want to think about how do we get these public goods, right? And really the only way is if you have some type of central governing body, right? That can observe what's the benefit to every single one person, figure out what the total benefit to society was, and then from there, set the optimal quantity for this public good. So we'll kind of talk through these. So I said it's non-rival already. We would also say it's kind of non-excludable, so anybody can use it. Right? So excludable goods, non-excludable goods, basically just the complements of each other. Excludable goods are going to be something that when someone owns this good, nobody else can kind of use it, right? Or at least they can give the right to use it, right? This is like most goods you would think about, like any kind of food you buy, right? It's an excludable good. And once you buy it, like someone else can't buy that exact same hamburger. Now they might buy another hamburger from the same place, but they can't have that exact same one. Like that's yours, that's your possession. Non-excludable, excludable is going to be something like parks, right? So once the park is built, once this public park is built, right, anybody can kind of use it. Right? Radio signals is another good one. Like the signals are out there. I'm sure there's like some really good examples with something probably to do with like IP address. I don't know, not IP addresses. Something I'm just not as savvy enough to know all the stuff behind the scenes there. Right? Anything that exists that anybody can use, right? Non-excludable. I then already kind of mentioned this idea of rival, non-rival. So the idea of rival goods is that once I use it, you can't use it. Right? So a rival good would be, like I said, kind of typical examples are like food, maybe airline tickets. Once I buy, or like a ticket to a baseball game or something, once I own the ticket to that seat, we can't have two people sitting in the same seat, right? It's a rival good. Once somebody buys it or uses it, no one else can. We then have non-rival goods. I saw like a really good example of this. Now these are public goods, like non-rival. I gave the idea of like national defense and interstate systems. But another good one that's maybe a little more relevant, you know, like since the creation of music has gone to like digital, right? I can go onto iTunes and buy some music. That does not prevent you from buying that exact same music, right? It's a non-rival good. Whereas before the music industry, once I bought a physical like CD or tape or something, nobody else could buy that specific CD or tape, right? There was kind of like this limited quantity. So now we've got a different scenario. So we've got rival, non-rival goods, excludable, non-excludable goods. So we've got different types and classifications. What I started out talking about, what we'll kind of think about today and in the next class, are going to be these public goods. So these are goods that are non-rival, so we can all use them, and they're non-excludable, right? So you using it doesn't prevent me from using it, and then also anybody can use it at the same time. So this is like the idea we can all benefit from national defense simultaneously, right? The other ones we have, we'll talk about the non-rival excludable goods, probably down. I don't even know if we'll get there by the end of Monday's class. That might be kind of after Thanksgiving break. Excludable goods are really things that we've basically been talking about the majority of the semester, right? This is kind of probably 90% of goods, right, are rival and they're excludable, right? Most of the things we buy are rival and excludable. Once I buy it, I own it. No one else can buy that exact same good, and nobody else it's excludable in the sense that like I can prevent people from wearing my clothes or from using my car, right? And then we have the common resources, which are rival. So once I use it, that kind of prevents the amount that's available for other people to use, but it's not excludable. Not everybody can use it. So the idea here would be I always think the best example, just and maybe this is just the way because I can relate to it the most. But I always think of like a pond or a lake in terms of fishing. So usually we think about these as like common resources. So these are things like fish in the ocean, right? If I catch a fish, it's rival in the sense that no one else, as long as I'm keeping that fish, like pulling that fish out of the ocean, no one else can catch that exact same fish, right? But it's not excludable in that anybody can go out in a boat and fish and catch these fish, right? Unless the government steps in and puts regulations on it, right? That's why you have to do like fishing permits, or I think about deer hunters. I know like that's what? It's gun season, right? In Indiana already? Okay. Michigan works a lot different. I think theirs is November something, but started Monday. Oh, okay. So that was close. I knew it was somewhere else. But that would be another good example, right? There's a populace of deer. It's not, if the government didn't step in, like go back 100 years, you could go out in your backyard and shoot a deer, right? It's not excludable. Anybody can do it. But it's rival in the sense that once somebody kills a deer, no one else can kill that deer again. And unless, there's some miraculous thing happening in science where we can predict that. So we'll talk about these different types of goods, specifically focusing on public goods today. People just pick up in this next class. We'll talk through kind of these definitions again. We'll start to think about highways and how different features of the same good can actually change its category, right? So different features of the same good could make it a common resource, a public good, a national monopoly, or a private good. Okay? So we'll pick up this next class. We'll kind of go back and look at that coast agreement, which is what we skipped today. I'll get that homework assignment up there so you can start chipping away at that. And other than that, I will see you guys on Friday.